Imagine if someone flipped a switch in the sky, plunging the world into eternal darkness. It's killing off 75% of all species on the planet. It sounds crazy, but that's what happened. Not once, not twice, but 3 times over the past 250 million years. Each time, life nearly went extinct during what scientists call a mass extinction event. But life still managed to find a way to survive and bounce back even stronger than before. What caused this incredible series of die-offs and recoveries? The culprits are so-called large igneous provinces, or lips. These colossal outpourings of lava have left their mark on every continent on Earth, and they continue to shape our planet to this day. Now, thanks to new research, we're relearning just how close we came to suffering the same fate as the dinosaurs during these volcanic hellscapes. And we're discovering why some survivors thrived while others perished. Most surprisingly of all, we're finding that these super eruptions may be linked to the asteroids that have also shaped life on Earth. But first, let us rewind the clock to understand what an LIP is and how it differs from your typical volcano. A lip is a massive collection of igneous rocks, those formed from cooled magma that spewed out of the Earth at roughly the same time. In other words, it's like one giant solidified blob of lava. The largest ones cover areas the size of France. To put that into perspective, Mount St. Helens, one of the most dangerous volcanoes in the United States, can only produce an eruption column about 30 kilometers into the air. But during the largest lip eruptions, columns of lava rose more than 50 kilometers up through the atmosphere and more than 100 kilometers out onto the surface. They were literally hundreds of times more powerful than typical volcanoes. Scientists aren't entirely sure how these gigantic eruptions occur, but when they do happen, they send a huge amount of carbon dioxide and other gases into the atmosphere. Some of those gases stay trapped in the atmosphere for decades or centuries. Meanwhile, the debris ejected during the eruption reflects sunlight back into space, which cools the planet. Eventually, though, the gases and debris settle down, and the sun's rays warm the surface again. This pattern of rapid warming followed by cooling has drastic consequences for living things. These 3 mass extinctions, driven by lips, all occurred when continents were drifting apart, which allowed magma to well up from deep within the Earth. So here's a brief history of volcanic hell on Earth. 252 million years ago, the breakup of the supercontinent Pangaea unleashed flood basalts, a type of lip in what is now Western and South Africa. Today, these ancient lavas are known as the Karoo-centered igneous province. Together, they covered an area of about 6 million square kilometers. That's comparable to the modern-day U.S. state of Texas. As this eruption continued over hundreds of thousands of years, its lava flows spread across the barren landscape. You can still see them today in places like the Fish River Canyon in Namibia, where layers of solidified lava drop dramatically down into the Earth. At first, this deluge of fire and brimstone devastated local ecosystems. But after the dust settled, lush rainforests began to appear around the surviving animals and plants. This created an environment that was even more hospitable than before the eruption. Well, until it wasn't. About 18 million years later, a second pulse of eruptions struck. This time, it was in what is now Siberia. The resulting Siberian traps covered an area of about 7 million square kilometers with lava and ash. These eruptions lasted for about 1 million years and produced a layer of ash 10 centimeters thick over a huge portion of the northern hemisphere. Not only did this darken skies over much of the planet, but it also choked waterways with ash and toxic gases. The temperature of the oceans dropped significantly. Survivors struggled to adapt to this rapidly changing world. And by the end of it, 96% of marine species and 70% of land vertebrates were gone. All told, this marked the most severe mass extinction in Earth's history. Yet life found a way to pull through. And just 66 million years ago, a third volcanic catastrophe struck. This time it happened in what is now the Deccan Traps in India. Their massive lava flows covered about 500,000 square kilometers. And as they spread out, they interacted with a familiar asteroid impact that you might have heard of before, the one that killed the dinosaurs. The Deccan Traps had been erupting for about 30,000 years by the time the asteroid struck. And although the asteroid undoubtedly dealt a death blow to life on Earth, the eruptions made things worse. Scientists think that together, the asteroid and the eruptions caused a chain reaction that wiped out 75% of species on Earth and 90% of those in the ocean. But perhaps surprisingly, the aftermath of these catastrophes paved the way for new life. The Cretaceous extinction left mammals free of their reptilian overlords. And suddenly there were few predators to compete with, and many resources available. Mammals diversified quickly, giving rise to early whales, dogs, cats, hoofed animals, and primates. Without the devastation wrought by the volcanic eruptions and asteroid, life on Earth may have continued much as it had for hundreds of millions of years. But how did these volcanic hellscapes alter the course of evolution? To answer that question, researchers are studying sites where fossils have been found preserved alongside the remains of ancient eruptions. By analyzing the chemistry of the rocks and sediments, scientists can piece together how the surrounding ecosystem changed after each eruption. For example, a study published in 2023 used chemical analysis to reconstruct how the Cretaceous eruption in the Deccan Traps affected the surrounding environment. The authors concluded that the eruptions led to a rapid acidification of the ocean that persisted for decades. This suggests that creatures unable to adapt to these conditions died off, leaving room for survivors like our fishy ancestors to thrive. But because these studies require carefully preserved fossils and rocks, it's hard to draw conclusions about what really drove the mass extinctions. Today, scientists are looking to distant planets to fill in the gaps. On Venus, for example, scientists believe that intense volcanic activity in the past led to a runaway greenhouse effect. If so, studying the composition of Venus's atmosphere could tell us what Earth might have been like during the worst of these eruptions. And Mars could teach us what happened after the skies cleared. Scientists are currently investigating whether ancient floods on Mars were the result of volcanic activity. If so, they could help us understand how life repopulated Earth after the skies cleared following the Cretaceous eruptions. But it's not just ancient lips that we need to worry about. Although they typically occur over millions of years, some LIPs are still active or have formed very recently. One such site is the volcanic island of Surtsey in Iceland, which began forming just 60 years ago in 1965. It was born from a fissure or crack in the earth through which magma surged. This created a new mountain and an island measuring about 2.5 square kilometers. But Surtsey is disappearing just as quickly as it formed. Surtsey is slowly being eroded away by waves crashing against its rocky shores. This dramatic display of creation and destruction highlights just how powerful these geological forces truly are. Another lip in the United States called the Columbia River Flood. Basalt group is thought to have formed over a period of about 400,000 years, starting about 17 million years ago. Its lavas once flowed as far north as British Columbia in Canada and as far south as California. In a site in Germany called the Eggersendottingen Igneous Province is thought to have formed about 145 million years ago. It was once home to a vast inland sea filled with hot volcanic waters. These LIPs, along with others like them, remain active even today, bubbling away in places like Yellowstone National Park in the United States and the Taupo volcanic zone in New Zealand. And they continue to spew out massive amounts of carbon dioxide, sulfur dioxide, water vapor, and ash. According to one study published in June 2023, the mere presence of these gases is enough to drive significant changes in the atmosphere, even if the eruptions themselves don't produce massive ash clouds. What's more, recent research suggests that lip eruptions may have been responsible for more mass extinctions than previously thought. Instead of acting as independent drivers of extinctions, these eruptions may have exacerbated the effects of asteroid impacts. In a study published in August 2023, researchers proposed that the end Permian extinction, the most severe mass extinction in Earth history, was actually the result of a combination of asteroid impacts and lip eruptions. The asteroid impact caused a spike in carbon dioxide levels in the atmosphere, which would have warmed the planet. But then the flood basalts released huge amounts of water vapor, which would have intensified the greenhouse effect and further increased temperatures. Taken together, the two would have caused global temperatures to rise by 4 degrees Celsius or more. So what comes next? Will we experience another lip eruption that wipes out life as we know it? Well, according to science, probably not anytime soon. But that doesn't mean we're completely safe. While the exact timing of these events is impossible to predict, scientists can look to the past for clues about what might happen in the future. As we learn more about the frequency of past eruptions, we can use that knowledge to calculate the likelihood of future ones. Then, by comparing different LIPs and analyzing the factors that contribute to their formation, we can identify which regions are most at risk. This will allow us to better predict when the next volcanic hellscape will strike and what form it might take. That knowledge could save countless lives. All told, these gigantic eruptions are a humbling reminder of the immense power of nature and its ability to shape the world around us. But they also show us that change, even on a catastrophic scale, can sometimes pave the way for new beginnings.